So one last thing that I'll show you with generics is that we can also write generic classes. So the concept is exactly the same. You could define some class, whatever it's called, thingy, and then it accepts a type. And then we can use that generic type, that parameter, within our class. So let's take a look at a simple example. Let's say that we have two interfaces. We're making an app where a user can create playlists. They can either have video playlists, like YouTube, or audio playlists like, on Spotify or something. So let's make an interface for a single song to start. And it just needs to have a title that's a string, and an artist will be a string or something like that. And then we can have a separate interface, and these would be way more complicated, but then we'll have an interface for video that has also a title, but instead of an artist, we'll call it creator, that's a string, and then we'll have, resolution as a string, just so we have something clearly different, right, between a video and a song, but it doesn't really matter. But now let's say I want to define a class called playlist, and I don't want to have to do a separate video playlist, which has, let's call this public videos of type video list equals an empty list, and then a separate one down here, class song playlist, which has a public songs attribute or property, which is an array of songs. So instead, I can say I want a class called playlist that accepts some type. It's a generic class. And then a playlist is going to have a list of something. We'll call it, Q. Sure. Q of type T array equals an empty array. And then we can have a function in here like, add that expects some element of type T. And then in here we'll do this dot q this dot q dot push that element. So now we have one class that is typed, but it uses a generic. So I could either have an instance of playlist, so new playlist of type song, const songs, right, equals new playlist of type song, just like that. And now I have to push, like if I do a dot add, I must provide a song, right? It's going to say that has to be a song. Whereas if I make a second playlist for videos, const videos equals new playlist of type video. And then I do videos dot add something to the queue, which I'm not even adding in, but just so we can see the type annotation, element is expected to be video. So now we can write a bunch of different methods that all are part of the class that all somehow use this T type. They might not need it, but if they do, right, we could have a remove element, a change order, whatever that is, these different methods, they all will probably work with T. But now we have this one class that can behave or that can suit different needs, right? A song playlist versus a video playlist. We've genericized the playlist class.